Okay, some basic applications here. Interest. When money is invested, it usually earns interest. Most students, that should say students, it says student. Maybe I'll fix that sometime. Or maybe I won't. We'll see. We'll see what the future holds. Most students are familiar with the formula I equal PRT, or interest equals principal times rate times time. This is the formula for simple interest, in which interest is calculated but not added into the account. However, most investments use compounded interest. When interest is compounded, the interest is calculated periodically, then added. That says add. Boy, I didn't proofread this very well, did I? Then added to the principal of the account. So, my bank account. Every month I receive a statement where they say you've earned $20 of interest, and they add that into my account. And so then the next month, when they calculate the interest, they're calculating the interest based on the sum with that extra $20. And so the next month I earn 21, and they give that to me. Then the following month they calculate the interest, again based on the two previous months where they added $20 and $21. That's the idea of compounding, that they calculate your interest and they give it to you. Then the next time they do the calculations, they're basing your interest on that slightly bigger number. Simple interest, they never, when you were doing applications of simple interest, and we did some back in chapter 1, they never talk about adding it back in. Simple interest is just telling you what the interest is, and they're not doing anything with it. And so no institution actually uses simple interest. Compounding is the idea that we're going to calculate the money every once in a while, add it into your account, so your account gets bigger, and the next time we do our calculations, we'll do our calculations based on that bigger amount. Now, there are two formulas for compound interest. After T years, the balance A in an account with principal P. Principal is how much money you initially put into the account. An annual interest rate R in decimal form is given by the following formulas. For n compoundings a year, and the compoundings are just how often the institution stops, does the arithmetic, and gives you your interest, how often they do that. For n compoundings a year, the formula is A equals P times the quantity, 1 over Rn raised to the nt. And for continuous compounding, and yes, it is mathematically possible to compound continuously. For continuous compounding, A equals P times E, the number E, raised to the RT. By compoundings, we mean the number of times the interest is calculated and added into the account. Common compounding terms are semi-annually, n equal 2, quarterly, n equal 4, monthly, n equal 12, weekly, n equal 2, daily, n equals 65. Note, you will need to have the above formulas memorized for the quiz and test. If this is this COVID year, there aren't necessarily quizzes, so I'm just going to put that there. Who knows? Maybe someday you'll be watching these videos and it won't be a COVID year and there will be quizzes. Best to have these formulas memorized. Compounding continuously is easy, PERT. This one's a little harder to memorize. So, example 7. Find the accumulated value of an investment of $10,000 for 4 years at an interest rate of 3.5% if the money is A, compounded semi-annually. So let's figure out what everything is. My principal is that $10,000. My time, T, 4 years. My R, 3.5%, which I say 0.035. Change it to a decimal. And then compounded semi-annually, that's n equals 2. And so now I'm just going to use my formula I have up there. A equals P times 1 plus R over n to the nt. So 10,000 times 1 plus 0.035 divided by 2 raised to the 2 times 4. And you're just going to do this on a calculator. And my advice is just type the whole thing into a calculator, pretty much the way you see it. 10,000 times 1 plus 0.035 divided by 2. Then depending on the age of your calculator, do whatever you need to do to get that exponent. I have an old calculator, so it's a little caret. And then when in doubt, put your exponent in parentheses. Now you could just as easily just go ahead and call that 8, and then you wouldn't have to worry about the parentheses. But in general, should I put my exponent in parentheses or not? When in doubt, put it in parentheses. And now we're just going to type that in there. So 10,000, 1, 2, 3, 4. There's 10,000, parenthesis, 1 plus 0.035 divided by 2 in the parenthesis. Exponent, whatever you need to have to do exponent, and when in doubt, use parentheses. So I'm going to put my exponent in parentheses and hit enter. And we get 11,488. This is money, so round to the 2 decimal places, 0.82. Do the next one. Same stuff, now compounded quarterly. So that's n equal 4, but everything else is the same. The principal is 10,000, the time is 4, the interest rate 3.5%, or that's 0.035. So A equals P times 1 plus R over N to the NT. So that's going to be 10,000 times 1 plus 0.035 divided by 4 this time, raised to the 4 times 4. And again, you're just going to do that on a calculator. 1,000 times 1 plus 0.035 divided by 4, raised to the 4 times 4. So 10,000 times 1 plus 0.035 divided by 4, raised to the 4 times 4. And we get 11,495.74, rounding to 2 decimal places because it's money. Then the last one we're asked to do here, continuous, that's that other formula. It's PERT. So my P, my principal, is still $10,000. My rate is still 3.5% or 0.035. Not that you can find interest rates at 3.5% anymore, but once upon a time you were able to. And my time is still 4. So I'm going to have A equals 10,000, E raised to the, I lost my train of thought, 0.035 times 4. And again, just on a calculator. So 10,000 E raised to the 0.035 times 4. So very much just the way I see it. Now let's clear all that old stuff out. Okay, 10,000. Then remember how you get E. Second ln. Second ln gives you E, and in my older calculator, an exponent, a little caret. In newer calculators, it actually just superscripts it for you. Then 0.035 times 4. In that parenthesis, hit enter, and we get 11,502.74. Now, reasonableness of answers. You're putting $10,000 into the bank and leaving it there 4 years. You are not going to become a millionaire when the bank is paying 3.5% and you're only leaving it there 4 years. So reasonableness of answers, after 4 years, we started with $10,000 and coming back with almost 1,500 more, not quite 1,500 more, that's reasonable. You're not going to become a millionaire after only 4 years of plunking your money in the bank. Now, the other thing I want to look at is look at all these answers. Compounded semi-annually, we got 11,488.82. Compounded quarterly, 4 times a year, 11,495.74, a little bit more money. And then continuously, so that'd be as often as you could possibly do the compounding, $11,502.74. So from kind of the smallest number of compoundings semi-annually to the most, that's roughly $14 more? Not a whole lot of money more. And so my point here, a little life lesson, the number of compoundings does help you earn more money, but it's not significantly more. So if there were any fees associated, say you go to this guy because, oh, it compounds continuously, I'm going to earn the most money. It was approximately $14 over 4 years. 14 divided by 4, we'll round that, roughly 5. No, it's not roughly 5. 14 divided by 4 is 3.5, I think. But, somewhere between $3 and $4. You're only getting $3 to $4 more each year. And so if you had to pay any sort of fees, say this guy came with a $10 fee per year, you're losing money. What makes a real difference in the amount of money you're going to get from a bank is the interest rate. But you will see advertisements that say, oh, we compound daily for maximum amount of money. Daily will do a little bit better, but not as much as an interest rate. So life lesson, the number of compoundings can make a difference, but what's important is the interest rate. Go for the highest interest rate. Okay, moving on to the last problem. In 1986, the explosion at Chernobyl nuclear power plant in the former Soviet Union sent 1,000 kilograms of radioactive cesium-137 into the atmosphere. The function f of x equals 1,000 times 0.5 x to the 30 describes the amount f of x in kilograms remaining in Chernobyl x years after 1986. If even 100 kilograms of cesium-137 remain in Chernobyl's atmosphere, the area is considered unsafe for human habitation. Determine if Chernobyl will be safe for human habitation in 2066. So all we really have to do here is figure out what number to plug in. So it says here, X years after 1986. X is years after 1986. So 2066 would be X equals 2066 minus 1986. And not trusting my brain today, we'll just actually ask the calculator what that is. That is 80. So we want to know what f of 80 is. So plugging that in there, 1,000 times 0.5 raised to the 80 divided by 30. And again, we're just going to ask the calculator to do that. So 1,000 times 0.5 raised to the 80 divided by 30. So 1,000 times 0.5 raised to 80 divided by 30. Pretty much just type it in there exactly how we see it, hit enter. And we get 157.49 to 2 decimal places. And it said that it would be unsafe if even there were still 100 kilograms. So this is still unsafe. Want to see some interesting pictures? Google Chernobyl and see how nature is responding to the lack of humans. See the buildings are left behind. They're kind of interesting. But end of this video, end of this section.